How to sketch reciprocal of a linear function. I'm Anil Kumar, and this video is for my students who are doing last minute preparations and they really don't have time to get into details. I have many videos in which we are working out details about sketching reciprocal function, but here we'll just do it in few steps. These are the steps. Look at the function. Here this function is linear, a straight line. Then get to the x-intercept. Now the x-intercept is a point where the value of the function is 0. What is reciprocal of 0? 1 over 0. That is not defined, so we will have a vertical asymptote at this point for the reciprocal function. Right? So the reciprocal function will have a vertical asymptote wherever the function has a 0. So first step is draw the vertical line and get full marks about this vertical line by also writing the equation, and in this case equation is x equals to the x value, which is 1, correct? Remember, this is not in the domain of your function. So that's the first point you have to look into. The second point which you have to look into are called invariant points. That is where the value of y is 1. So value of y is 1, so that means this value it crosses, so that is the value which is 1, or minus 1. This is minus 1. So minus 1 is here. So these are the points on your reciprocal function. These are called invariant points, right? So let me write it down here, invariant. Correct? So these are invariant points. Let me show them so that you don't forget to mention these points. Now third thing which you have to look for is that as you move to a higher value positive, if you are on positive side, reciprocal will be positive. If you are on the negative side, reciprocal will be negative, correct? Now, as the function's value increases, reciprocal decreases. So we'll start from the invariant point and move towards the left side. Now we can identify some points. For example, here we have 4, so we are looking for 1/4 of this value. 1/4 will be kind of here, right? So this is 1/4. 1/6 of the value. As we go higher, we go lower here. So on the reciprocal side, we have to start from this invariant point, correct? Now y-intercept is 2, that will give us a value of half, so we get this point. So these are the points of our interest, and that leads to horizontal asymptote, correct? And the equation of horizontal asymptote is y equals to 0. That is your horizontal asymptote. Now the function value is decreasing. This is lesser than 1 but greater than 0. Still positive, reciprocal will be positive. If it is half, reciprocal will be 2. If it is 1/3, reciprocal will be 3. If it is 1/4, 4, and so on. So you'll find this to be increasing. So we get this part of the graph, which is as it approaches 0 from positive side, we are approaching infinity, positive side. And that gives you equation for vertical asymptote. So we'll say vertical asymptote is what? The vertical asymptote we already defined, x equals to 1, right? So that is approaching the vertical asymptote, which is x equals to 1. That's good. Let's get to quadrant 4 now. Starting with the invariant point, which is minus 1. If I move towards right, f of x is increasing, reciprocal will decrease, negative will be negative. Now identify some points. Minus 2, reciprocal will be minus half, which is here for us. And then let us say minus 4, 1/4, correct? 6 minus 1/6. So that is how it is going, right? So that is approaching the horizontal asymptote. As the value of the function is between 0 and minus 1, fractions, reciprocal will be higher but negative, right? So at half it is going to be 2, right? 1/3 it is going to be 3, and likewise increasing. So we get like 1 over x graph. Do you see that? So the shape should be like 1 over x with horizontal and vertical asymptotes identified, invariant points marked. You have full marks for this, correct? So let me summarize. Now you can actually pause the video and need not even go forward, but let me summarize all these points. To start with, we should look at what? So these are a few points which you should be considering, okay? And I don't know how many bullets to put here. We'll stop. Okay, so the first point is we are looking for f of x, and then what happens to reciprocal of the function. We look for x-intercept. And for the reciprocal, we get vertical asymptote. That's it. Then look for f of x equals to plus or minus 1. In that case, r of x is also plus or minus 1. These are invariant points. Is that okay? And then we are looking for few points where f of x is greater than 1. In that case, r of x is less than 1 but greater than 0, which is in fractions. Do you understand? So you get one part of the graph starting from the invariant point. As f of x is greater than 1, r of x is positive and is approaching the horizontal asymptote, right? So as f of x is approaching infinity, positive, then we will see that r of x approaches 0 from positive side. If f of x approaches, I should show arrow here like this, negative infinity, r of x should approach 0 but from the negative side, and these give rise to the horizontal asymptote, right, which is in this case horizontal asymptote y equals to 0, correct? Now as f of x approaches, I should say this point A here, right? As f of x approaches A, r of x approaches infinity. A from positive side, it approaches positive infinity, and if f of x approaches A from negative side, reciprocal function approaches negative infinity, correct? These are very critical points, and this is the behavior near the vertical asymptote. So that leads to vertical asymptote, and the equation is x equals to a. In our case, x was equal to 1. So if you keep these points in mind, you can immediately sketch a wonderful reciprocal function from a linear function and get 100% marks. That is what it's all about. Subscribe to my videos and learn much more about functions. Thank you and all the best.